Don't tell Miss Trammell. I snuck into her room and grabbed some stuff and trying to figure out how to do pH and acids and bases and all this kind of stuff. So I've got this little experiment I want to show to you. The first thing we do is we take a look at a base. This is called potassium hydroxide. All right, bring it up here. You'll see potassium hydroxide. Okay, take a couple of drops of potassium hydroxide and put it in this little itty bitty beaker, and you'll see there's just a little bit in the bottom of that. And then I take a little bit of this substance. This substance is actually something called phenolphthalein. And look, the phenolphthalein makes it turn this beautiful, beautiful magenta. And that's because the phenolphthalein activates when it's in the presence of a base. A base is a hydroxide, OH. But watch what happens to this if I add a little bit of acid. Put a little bit of acid in there, nothing happens. Put a little bit more acid in there, nothing happens. Shake it around, no big deal. Put a little bit more of acid in there, and then eventually it disappears. Now that white is just because the way the acid works with the phenolphthalein. But you take a look at this and it goes back this way. Now if I grab the potassium hydroxide again, we get this to turn back the other way. Hoop! It disappeared. Turn back the other way. Oh, whew. I wasn't sure what I was doing there, but if I put a little bit of the acid back in, it goes back the other way once again. And so this reaction, we're able to tell where the point is where it turns from an acid to a base. Now there's another way to do this, and that's using the same substances, but we use what's called a set of burettes in something called titration. Let me show you that. So what I have here is a set of burettes. In one of these burettes is an acid, and the other burette, it is a base. And it's got these little numbers and things on them that make it really cool so that you can be really, really exact in what you do. So you take a little bit of the acid and you pour it into this beaker, all right? So you pour it into the beaker. As you can see, just a little bit of acid in the beaker, and you add a little bit of this phenolphthalein. And the phenolphthalein, again, phenolphthalein is what's called an indicator. If you have hydrangeas around your house and they are blue, it's because the ground is slightly acidic. If they are pink, then your ground is slightly basic. So you can actually use hydrangeas to test your soil. It's kind of cool. So now what you'll do over here is you'll take this and you'll add a little bit of base. Now you see what's happening is the base starts pink, goes away. Now what that means is that the base and the acid react to form a salt and water. The problem is there's still too much acid because the pink comes when the base has more pieces, right? So we just have to keep adding a little bit more. So we'll go in here, we'll add a little bit more, a drop at a time, and you'll see if I add a lot, there's the pink, but then it starts reacting, and the reacting makes it disappear. So it's not magic. What it is, too much acid, not enough base. The more base we add, the closer we're going to get to that middle point to try to describe what's happening. And so we keep going, 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 we keep going. We spin it around, and we think we have it. Oh, it goes away. And then we do it again, and it's close, it's close. It goes away. A little bit more, and then it goes away. A little bit more, and voila. More base than acid. So guess what we get to do? We come back over here. We add a little bit of acid to it, and we spin it around, and we spin it around, and whoosh, disappears. Now what happens in a titration experiment is we go back and forth. We add a little base, we get it to be pink, we add a little acid, we get it to clear, And eventually, when one drop from this burette and one drop from this burette change it back and forth from pink to clear, we know we have equal amounts of acid and base. And they have reacted together, and you have exactly the same amount, not in volume, but the same amount of ions, the same amount of hydrogens, and the same amount of hydroxides in this substance. So titration is a pretty cool experiment, don't you think? Let's get our simplest view of what acids and bases really are. So an acid has an extra hydrogen ion in it, or it has lots of extra hydrogen ions. So hydrochloric acid is very strong. It has lots of hydrogen ions. Whereas vinegar is not quite as strong. It has less hydrogens in it, but it still has extra hydrogens. The other option that we have is a base, which has an OH in it, or a hydroxide, and it's negatively charged. So you have sodium hydroxide, ammonium hydroxide, or anything with extra hydroxides in it. Those are powerful bases. Now, if we take a look, if we bring these two together, you see one of them is a plus, the other is a minus, so these would react and create HOH. And so this actually is water. Water is made when you put an acid and a base together. Now the other pieces make something called a salt. You can talk about that later with Mrs. Trammell. But the idea here is you have acids and bases come together and make water. Well, if I had a beaker of water, do I have the same number of acids and the same number of bases, the same number of hydrogens and the same number of hydroxides? The answer is yes, right? If we have a pH of 7, we have the same number of hydrogens and hydroxides. This is called neutral. If you have a pH of less than 7, it's an acid, and you have a pH of greater than 7, right? If it's greater than 7, it's a base. But how do we get that number 7? The number 7 seems really weird, that why 7 would be what we would use, but it's actually pretty simple. If you take a beaker of water, 1 out of every 10 million molecules breaks apart. Every one of those molecules that are in that beaker, 1 out of every 10 million breaks apart. The problem is that number's awful big. So what we do is we use what's called the logarithm. You'll find that on your calculator. It says log. Ever wonder what that was? No, it's not a piece of wood that was out in the wood, that's outside in the forest and the tree falls and you have a log. No, that's not what it is. What it is, it's a mathematical function. This is equal to 1 times 10 to the negative 7th, right? The negative means that it's in the denominator. You'll learn this eventually. The 7 is the number of zeros. Now, if you take the logarithm, if you take the negative logarithm of 1 times 10 to the negative 7th, what happens is this. You take this number and you put it in your calculator. Then you take the logarithm of it, take the negative, and you get 7. The magical number 7. That's the same number as the number that we have right there. So, the mathematics is a little bit difficult, but hopefully this will give you an idea of why the 7 even appears in our function and what acids and bases truly are. Have a nice day.